Hey everyone, this is Bradley Bush again with another algebra video. Today we're talking about partial fractions, and here's our to-do list. First of all, we will talk about the big picture. I want you to see a bird's eye view, so I want you to see the forest, not necessarily the trees, and that will help you when you are looking at the tree. So the second part will be a worked example. There are 4 different types of problems you can see in partial fractions. I'll talk about that a little bit later in the video. I have videos on all of them, but this one specifically is distinct linear factors. So let's get started. So do you remember adding fractions? Hopefully you're not cringing right now because fractions are your friends, as we all know. So if we take these 2 fractions, 1/2 and 3/5, and we have to add them, the first thing we did was we're like, hey, they don't have a common denominator, so you can't add the fractions unless they've got a common denominator. And so we said, well, 2 and 5, those are both unique factors. They don't have anything in common. So to get the common denominator, we just multiply 2 and 5. So 10 is our common denominator we're hoping for. The left one, 1/2, I've got to multiply by 5/5 to get the 10. And they're on the right, we're like, hey, let's multiply by 2/2 to get the 10. So 1 times 5 in the top gives us 5, and 3 times 2 in the top gives us 6. And now we've got common denominators. We can just add the tops and keep the same denominator. So we have 5 plus 6 in the numerator, and that gives us our answer of 11/10. So this has a point. I know you're probably thinking, does this have a point? But it does, really. Just stay with me. So 11 out of 10, or 11/10. So adding or subtracting rational functions. So these are fractions, but they now have polynomials in the top and in the bottom instead of just constants. So this is like adding fractions on kind of steroids. So do you remember how to do that? It's almost identical to what we did before in the adding fractions, because we're just adding fractions. The fractions are just a little bit more complicated. So if we start with 3/x minus 1, and we're going to subtract from that 2/x plus 2, then again, we've got to get a common denominator. And our common denominator, since x minus 4 and x plus 2 don't have anything in common, we multiply them together, and that gives us our common denominator. So as we're looking at the common denominator, our first term, the 3/x minus 4, is missing the x plus 2. So we'll multiply top and bottom by x plus 2. The second term, the 2/x plus 2, is missing the x minus 4. So we'll multiply top and bottom by x minus 4. Then we have to distribute the 3 through the x plus 2 on the left term, and the 2 through the x minus 4 on the right term. 3 times x plus 2 gives us 3x plus 6, and -2 times x minus 4 gives us -2x plus 8. And we're all over that same common denominator. So when we gather up our like terms, we have 3x minus 2x, that just gives us a single x, and the 6 and the 8 give us 14. So there we go. We have the answer. So you're probably asking yourself, what are partial fractions? And I kind of hope they're like partial cookies, because then I'll really like them. Here's the punchline. When we're adding or subtracting rational expressions, so fractions with polynomials in the top and in the bottom, and or bottom, or both, when we're adding and subtracting, it's just like we're getting in our little car and we're going from the left side to the right side. Because we start with the 3/x minus 4 minus 2/x plus 2, and we end up with the stuff on the right side, right? One single thing. That's just adding or subtracting. But what if we are over here on the right side and we're like, hey, we want to go back. We want to get in our car and go back home. That is exactly what partial fraction decomposition is, or for short, partial fractions. All it is taking a fraction and breaking it up into the sum or difference of a few smaller, simpler fractions. Just going backwards in the addition-subtraction process. That's it. So if this is all you need to know, if all you need to know is what is partial fraction decomposition, then you're good to go. You can stop watching the video. But for the rest of us that need to know how to solve them, how to actually go from this right side to finding out, well, the 2 is here and the 3 is there and there's a negative, and these are the denominators, then let's keep going and we'll actually do a problem. Just as a reminder, we have 5 types of partial fraction problems. We will be discussing this first one in this video. I have other videos to discuss the others. Number 5 isn't really a unique category. It just says you can combine 1 through 4 and come up with different types of problems. But today we're focusing on number 1. All right, here we go. We're off. So the question we have is find the partial fraction decomposition of x plus 14 divided by x minus 4 times x plus 2. So this is the problem that we were looking at earlier. Well, the first step, I've got a bunch of steps over here on the right in red. So that'll help guide us through this process. And you can use these, generalize these to any problem that fits this category of distinct linear factors. So the first step is find all unique factors in the denominator. And luckily, we already have. So x minus 4 and x plus 2, we've got 2 of them. 2 unique factors. Second step, are these factors linear or are they quadratic? How do we know? Well, it's by the exponent on the variables. Here in the denominator, we see a 1 on the first x and a 1 on the second x. Well, you don't see them because when they're there, when there's just a 1, it's implied and it's not written. So we know that 1's there. If there wasn't a 1, then we would have seen something like a 2 there. But we don't see a 2, we just see nothing. So we know that there is just a 1. So the answer to this question is they're linear. So that's good. We know that we are in the correct category and we can follow the steps here. So we've got 2 unique linear factors. So step 3 is set up the problem. So because we have 2 unique linear factors, x minus 4 and x plus 2, we're going to split up. We're going to assume that this term on the left kind of looks like a drawing of a face. And he's thinking about all this stuff, and there are his eyeballs. He's looking down, and there's his mouth. Okay, sorry. I need to go back to what I'm doing here, right? But you saw it. I know you all saw it. So because we have 2 linear factors, we're going to assume that this left-hand side splits into 2 different fractions. We don't know what the numbers are that go up top here yet. So we're just going to represent those numbers by A and B. You can do X, Y, you can do X1, X2, you can do whatever you want. They're just variables that represent numbers that we need to find. Because once we find those numbers, we'll be done. And we will have effectively split up the stuff on the left into 2 different fractions that are added together or subtracted. So here we go. Step 4. What we want to do is we want to combine the terms on the right. So we're combining this right here, the a over x minus 4 and the b over x plus 2. We can't combine those unless they have common denominators. So here we go with the common denominator stuff. So really we're just adding two rational functions here, right? Something that we just did a review on a little bit earlier. So we should be prepped and ready to go. So the first term, the a over x minus 4, is missing the x plus 2. So let's have that. So we multiply on top and bottom by x plus 2. The term on the right is missing the x minus 4. So let's multiply that on top and bottom. X minus 4. Now we can add them together because they both have the same denominator. And we can put them both over the same denominator. So that a times x plus 2, and we can add that to the b times x plus 4, x minus 4, and it all goes underneath the same common denominator. Awesome. So now we've got to do some distributing, because you can see that we have an a out front that needs to be distributed to the x and the 2. The b needs to be distributed to the x and the minus 4. What do we get after we do all of this distributing? Well, a times x gives us what? Ax. A times 2 gives us a2, or 2a. a2, that kind of looks like az to me. Let's do 2a. There's no reason for that, it's just my OCD. Now b times x gives us bx, and then negative 4b. Awesome. So now we look at this and we need to rewrite the numerator on the right to look like the numerator on the left. And then we're going to compare the coefficients. In other words, we have two fractions here. A fraction on the left, a fraction on the right. We are saying that they're equal to each other. If they are equal to each other, the denominators are already the same. So that's good. If these are really equal, then the thing on the top on the left has to be equal to the thing on the top on the right. So we need to make the thing on the top, on the right, the numerator on the right, look like the thing on the left, so we can compare the coefficients and figure out. So in other words, we have an x, and then we have everything else that doesn't have x on the left. So let's get together everything that has an x in excuse me. We have an ax and a bx. So let's put those together. And we do here ax and bx. And then everything else we have here. We have the 2a and the minus 4b. So we have everything with an x and everything without an x. That looks kind of like what we have on the left. So now we can see we can factor out an x. If we take this x and we pull it out front, and it's now sitting here, what's left? Well, just the a and the b. And then everything else that's left over is just brought down. So we can now look at this and say, on the left, we have an x, and in front of it, there's a 1. On the right, we have an x, and in front of it, there's an a plus b. So if these two fractions are indeed the same, then a plus b has to be the same as 1, or it has to be equal to 1. And that gives us our first equation. A plus B has to be equal to 1, or these two equations aren't the same. In other words, this equation is not the same as this equation. Sorry, this fraction is not the same as this. The fraction on the left is not the same as the fraction on the right if A plus B does not equal 1. So we can do the same thing with all of the terms that don't have an x. So 2a minus 4b has to be equal to 14. Or the two sides, the left side and the right side, aren't the same, right? And that's what we want. So there we have our second equation. 2a minus 4b has to be equal to 14. Now we're back into the world where we have two equations, two unknowns, and we solve that system. This is a fairly simple system, so that's great. Let's do it. If we're looking at this, we can, if we multiplied the top equation here by 4 and then added it to equation number 2, we would cancel out the b's. So let's try taking equation 2. So my equations all have numbers with circles around them. And so this is equation 2 plus 4 times equation 1. So here we have equation 1 with a 4 multiplied out front, and we have equation 2. So when we multiply the 4 in, what does that give us? What color do I want to use? Sometimes the only thing that you have to choose is what color you want. And it's a really hard choice. I know that might sound crazy, but it's true. So 4 times A gives us 4A. 4 times B gives us 4B. And 4 times 1 gives us 4. And we will call that equation 1.1 because it came from equation 1, but it's not the same as equation 1. So it's our newest version of equation 1. So equation 1.1, and then we have just equation 2 down here. We'll do 2 in purple because that's what it was already. 2a minus 4b equals 14. Then when we add these two together, we get 6a, and the b's cancel, and we get 18. So what does that tell us? Divide by 6 on both sides, and we see that a equals 3. So that's fantastic. We have the A. Now we can take that and put A equals 3 back into one of the original equations. Maybe equation 1 or 2, and solve for B. So let's take equation 1 because equation 1 was fairly simple. A plus B equals 1. We know what A is. We say A is 3, so instead of having A there, we're going to have 3. So 3 plus B equals 1. If we subtract 3 from both sides, then we get B equals -2. So B equals -2 is our next answer. So we have A equals 3, B equals -2. We've found all of the coefficients. So now we just have to state our answer. Instead of having A, here we have 3. And instead of having B here, we have -2. So this is exactly the answer that we had in the review at the beginning. The only difference is here I have the negative with the 2, but notice I could put the negative out front, and this could be negative Let me write that maybe not in highlighter. This could be negative here, and this could be a positive here. Either way is okay. But this is your answer. We just took the fraction. We got in a car and we went home, right? We took the fraction and we went backwards and split it up into two smaller fractions that were added or subtracted together. That's kind of cool. It's kind of a cool idea that you can do that. So they may make this problem harder. So you could see these different types of problems. These are the other four types of problems, other three types of problems that I discussed earlier with a little bit of explanation. So category 2 was repeated linear factors. So that's kind of what we like what we did today, but instead of having just one of these x minus 3s, we've got two of them. So if that happens, then you again do the same thing we did with unique factors. You put a spot for each unique factor, so x and x minus 3, but because they're two x minus 3s, you do the x minus 3 to the first power, and you do the x minus 3 to the second power. So you just do one for each of the exponents until you reach whatever you have. In our case, we had 2. The third category was non-repeated prime quadratic factors. So instead of having a 1, we have a 2. The only difference with these is instead of having just a constant up top, we have to put something that kind of looks like a line. Instead of having just an a, we have bx plus c, or constant times variable x plus constant. But we still, things are the same, we still have one fraction for each of the unique factors. Or we could take these two ideas and combine them, meaning we could have a quadratic that repeats. So if you're following the pattern you're seeing here, you're probably thinking, all right, well, unique factor x minus 2, there's an a over x minus 2. Now we've got another unique factor, x squared plus 2x plus 4. That's a quadratic, meaning it's got a 2 over the exponent, and it's prime. It can't be factored. So, and we've got 3 of them. So we do 3 of them. We have this factor, which is x squared plus 2x plus 4 to the first power, and then to the second power, and then to the third power. And above them, we have that line-looking thing. Instead of just having an a, we'll have constant times x plus constant. So I just keep going down the alphabet for all my constants. So it would be bx plus c in the numerator, and then dx plus e, and then fx plus g. Hopefully you don't have to do a problem that is that big, because that would be pain, but you can see the pattern that's followed. And that's it. I think you guys have should have really good understanding now of what partial fractions are and how you can solve a partial fraction problem that has linear unique factors. Thanks for watching.